In this section, we're going to tackle the kinetic molecular theory of gases. And the ideal gas law explains how gases behave, but it does not explain why they behave the way they do. So in 1857, Rudolf Clausius summarized over 100 years of work in 5 general statements known as the kinetic molecular theory. So we have to tackle 5 general statements of the kinetic molecular theory of gases. The first statement says that gases consist of large numbers of molecules in continuous random motion. So if you have a container of gases, they're moving around, they're not standing still, and they're in complete random motion. Okay? The second statement is a combined volume of gas particles is very, very small compared to the volume of the gase's container. Okay, so the particles themselves are tiny compared to the particles. So we have a lot of empty space in this container that's filled with a gas. The third statement that Clausius noticed was the attractive and repulsive forces between gas molecules are negligible. So we have very, very small attractive and repulsive forces from the gases. They're moving around very fastly in continuous motion, so there's not a big attraction or repulsion between the particles. Collisions between gases are perfectly elastic. That means our average kinetic energy is conserved, and as a consequence, our average kinetic energy does not change with time. Okay? The fifth statement that was proposed in this kinetic molecular theory is that our average kinetic energy is going to be proportional to the temperature. So as we increase the temperature, we are going to increase the kinetic energy of all of our gas particles. So these 5 statements here make up the kinetic molecular theory of gases, and in class we'll go over some examples and some visuals of how each of these statements are happening.